Hi, this course is on sentiment analysis. We will be building a logistic regression model and use it for sentiment analysis. Now let's understand what sentiment analysis is and why do we need it. Now sentiment analysis is a natural language processing technique used to determine when data is positive, negative or neutral. That is, if my text data that I have is actually showing me a positive response or a negative response or a neutral response. Now sentiment analysis is often performed on textual data to help businesses monitor brand and product sentiment in customer feedbacks and understand customer needs. Now we go on to project details. This project is divided into three parts. That is building our sentiment analysis model, then building our web application, and lastly deploying it to Heroku. So first, we will build features from our text data as ML models can't have string as input, meaning we can't directly use text data. Now second, we will build a logistic regression model that won't be actually the class that we use in sklearn, but our own logistic regression model to predict sentiment in the data. The next part is we build our web application. So we will be building a Django project as our web application, and it is based on Python and does a lot of handholding for you. So whoever doesn't have much experience in web development can definitely be able to use this. Lastly, we deploy our project to Heroku. And with this, we will now start working on our first part of the course. In this course, we will be building a logistic regression model which will help us in sentiment analysis. In real life, there's abundant text data coming from various sources like Instagram, Facebook, blogs, compendiums, etc. Now we can actually harness this data and actually solve a lot of real life problems using them. We are starting with importing libraries, and as you can see, we have NLTK library which will be used in sentiment analysis, and we have Ray library which is used in string manipulation. The next thing you can see is something called nltk.corpus. Now, this corpus package actually holds data set which are used for maybe text analysis, for maybe training models, for maybe finding inferences. So it has a lot of data, and from that we are finding our Twitter samples data set. So this has positive tweets and negative tweets with its class labels, that is positive and negative. The next you can see is NumPy, which is used in array manipulation or array handling, integer and maybe uh, manipulating float values. The last is Pickle. So Pickle is actually used to load and store our model or maybe some important data from the disk. So before we move forward, I would like you to go once at this link and see how logistic regression actually works and what is the math behind it. Since we are building a logistic regression model from scratch, this would be the needful. So with this, we come to the first part, that is processing tweets. So I have built a function named process tweet, which is actually doing three things simultaneously so that I'm able to pre-process my text data. Now, first of all, you can see I'm using the layer library and using the sub function. So sub function is actually like looking out for strings and removing the unwanted part. Let's say the string or maybe the text data has numbers, special symbols, or maybe URLs present in them since they are tweet. So we are removing all of that. And another last you can see is a basic example of how I am removing the hash symbol. After that, you can see the tokenizer or tweet tokenizer. So tokenizing is a function where we take a string as input and return a set of words that were in the string. For example, you can take a string, let's say, I am learning. So the output of my tokenizer would be I am learning. So it would be a list of three words that are I am learning. And we are using that function. So now you can see the next thing is we're using a for loop for further cleaning. The next thing you can see is a stemmer.stem function. This is basically I'm building an object of the porter stemmer class and then using the function stem in it. Now let me just tell you what this stem function does. Let's say you have a word that is learning. So if I send this word into my stem function, it would give me learn. Or let's say the word is works. If I put this into my stem function, it would return me with work. So you can see that the base word, may we use actually removing all the suffixes from the word, it is returning me. So this is what stem function does. Now the next part comes is building build freq function. So what we are doing in build frequency, actually build freq function, is finding how many times each word has come in my vocabulary, that is in my corpus, and in the or maybe the data set, and what it is having its class as. Meaning, let's say the word was learning. Okay, the learning maybe have come in the corpus, say 12 times. Okay, and each time it has come in a positive tweet. So the learning will have a positive class that is, let's say, 1 and has come 12 times in my corpus. So that is stored in my frex or maybe frequency dictionary. You can see that the dictionary is being called out here. And the positive or negative class is sent in my bias variable. You can see that it has an mx1 array Cartesian with the sentiment label of each tweet, that is either 0 or 1, taking 1 as my positive class. Now you can see that how this function is working. Let's say this was my whole corpus, meaning this was my whole data set. Okay, so now it has 1, 2, 3, 4, 5 sentences. Okay, and for each sentence there is a class defined if it is a positive or a negative tweet. So I can see that I am happy is a positive and the rest are negative. I'm tricked, obviously negative. I'm sad, again negative. So you can see that once I'm sending the tweets and wires into my build frequency function, it is returning me with a dictionary having the word, having the class, and the number of times it has occurred. You can see that happy has occurred only once, so it's showing 1. But you can see that tired is actually uh, being here, tired. Yes, I am tired and I am tired 2 times. So it has given me 2 times with a class of 0. Now this might occur that while working on the code again, you might be asked to download Twitter samples and stop words. So just uncomment this part and download both of these data sets because they will be used later on. As you can see in my process tweets function. Yeah, so this is the part where we're calling out the data set and storing it in the variable all positive tweet and all negative tweets. Again, we are just splitting the data for making it into a training and testing class. Now this is just accumulation of all the training data and the same for the testing data. Now you might be a little confused as to what we have done here. So we are actually building our target variable. How? It is like we're building an array which is storing all the class values, the 1 and the zeros. Now, since I already know that I first inserted the train pos, meaning the positive tweets in my train X, so the here in my Y or target variable, I'm storing that number times of 1. So this is the code for that. The similar I'm doing for the number of zeros. Now once this has already been done, what I'm doing is using my build frequency function. I'm calling it frequency from now on. So build frequency function to use it and build my features from the actual data set. What we had done above was just using a very small sample to understand what the function was doing. Now we are doing this for the whole data set. You can see that the frequency is a class dictionary, and from here you can see that how many number of words are present in my corpus or data set. So we have 11,346 words. Now you can see that this is the actual tweet inside my data set, just one of them, which is maybe the username. Yeah, suppose she was lol and something something. So after my process tweet, it is giving me yeah, suppose, lol, chat, bit, x, and a smiley face. So you can see that from this unprocessed data, we have this processed data. You might be thinking, suppose it doesn't have an E at the last. So this is because we have been using the stem function. Now, what stem function sometimes does is it isn't able to totally understand the base word and sometimes remove maybe the last few characters, let's say, with the suffix itself. But again, it understands what this word means. So unlike most, we will actually build a logistic regression model from scratch. And the first thing we do is implement a sigmoid function. Now, if you know the formula of sigmoid function, you will understand clearly what has happened here. We're just taking the negative of z, that is the input, and then we are taking the exponential of my new negative input and using it to get my sigmoid. If you don't understand this part of the code, I urge you to go back to the top and use that link and understand what logistic regression is and how the math behind it works. Now, the next part is gradient descent. So before understanding what has been done here, why has it been done here, just understand what the inputs are. X, matrix of feature which is of the order m and n plus 1. The next is corresponding label of the input matrix X. This is like a matrix holding all of my data set in rows. Say tweet number 1 is in row number 1, tweet number 2 is in row number 2. And for the same, there is Y, meaning tweet number 1's class, that is maybe 1 or 0, is in Y's first row. Similarly, in the second row, and so on. Now, there are two new terms, theta and alpha. So, theta are just the weight of the dimensions. Before we move forward, just understand the input this function takes. Now, this function, gradient descent, takes x, y, theta, alpha, number of iterations, that is num iters, as its value or as its input. So the x is a matrix of features that we have been building above, having a order of m, n plus 1, and then y is the corresponding label, meaning 1 or 0 are stored in this y correspondingly for x, having a dimension of m, 1. Theta. Now theta is the weight vector meaning the weights of this corresponding matrix of X, where weights are usually, if you have already understood logistic regression, are the like like here you can see this B1, B2, B3 are the weights for my feature set X1 and X2 here. So this is what we have been actually computing in my gradient descent function. Now simply you can see that we are computing the cost and the theta. Now the formula for this is, as you can see, the cost having my hypothesis and my actual class label is using the minus of log of my hypothesis if my class label is 1. Similarly, minus of log 1 minus hypothesis function if my class value is 0. So this is what I have implemented in my cost function here, and the code is here. This is my log function. This is taking transpose of a matrix. This is again log function and again transpose of a matrix. Lastly, we are multiplying this using the dot function. Now similarly, we are computing theta, which is using another variable named alpha. This is called the learning rate. And after we have done this, we go for extracting our features. Now we're using the frequency dictionary, okay, which we had actually, built using the build frequency function. We take the frequency dictionary and all the words in our tweet. We look how many times each has occurred and add them. You can see we are adding them here and we are adding them here for our positive label and for our negative label. And there's a bias term that we have put so that unless all the tweets are 0, we get the value here 0 and again 0. We don't actually have a model which has zeros in it. Now we test our training data. So I've just put one tweet with all our frequency dictionary and it gives me a value of this. Now try to understand what all these three numbers mean. Usually when we get a data set, we have a lot of features and columns. Let's say iris data set, it has 6-7 columns having all numbers. But here we just have text data. These three numbers are actually feature set that we have built using, just as I said, build frequency function and extract features function. Now build frequency function builds a dictionary having words as keys and the number of times they have occurred in the corpus as values, which I had also shown before. So we extract features and some of these values are the features that we have extracted for positive and negative words. Now you can see that if I have built an hypothesis function like this, so I have my weights or weight vectors as B1, B2 and B3, where I've already defined B1 as 1 and B2 and B3 are defined, not defined, but calculated here. And we have X1 and X2 as our features that are positive and negative words in feature set. Now we are training our model using all of the frequency function, the extracting function, the gradient descent function. You can see we are using the gradient descent function here to get the values of my cost and theta. Similarly, we are using the extract feature function to get all the features. Now we have built a predict tweet, basically a function which predicts the class of the tweet. And again, it's using my extract feature and sigmoid function. Now we finally have our test logistic regression function that is taking my test values or maybe the test features and again the classes of those test features, my frequency dictionary and lastly the theta that we have computed. Now you can see that I've used the text logistic regression function and it gives me a accuracy of 0.995, basically 99.5% of accuracy, which is very high. Again, I have finally defined a predict tweet function where you can just send your tweet and it returns you with positive sentiment, neutral sentiment, or negative sentiment. And let's say I have defined my tweet as it is so hot today, but it is the perfect day for a beach party. And when I send this into my pre or maybe predict tweet function, I can see that it is returning me with a positive sentiment. So with this, the first part of the course where you build a logistic regression model from scratch for sentiment analysis is complete.
So now we come to the second part of this course where we are building a web application to use our sentiment analysis or sentiment prediction model. There are some steps to be taken before implementing and using this code. First, it has been implemented in Django as the backend. First, we build an environment for our project. Now, there are many ways to build environments for Python libraries and such. And if you are using PyCharm like myself, you can just simply go to files, settings, and yeah, in settings you can see this project and you have a project name here. Now just go to the project interpreter or maybe project structure. In project interpreter, you can see that there's a project interpreter written here. This is basically telling me if there's a already existing environment setup or you can build a new one here using add. Now you can see that in my environment that is named sent underscore lg, all of these packages are downloaded. And with this, we come to the second part, that is downloading our or maybe installing our packages or dependencies. So wherever you have made a project and wherever your environment is set up, go inside that and see wherever your requirements.txt file is present. If I close all of this, you can see that my requirements.txt file is inside my site directory. So I'm going in my site directory. Now here you have now reached this part. So you can directly write a code that is pip install. Oh, sorry, not pip install. Yeah, actually pip install. Oh my god. Pip install requirement requirements.txt. Once you run this code, all of that that is present in my requirements.txt, you can see here, all of these packages will be installed. Now, once this has been done, you can now run the app. There's one last code that you have to run, which is Python Python manage.py migrate. Now, this is actually a command that is present in Django, not in Python, where you are simply calling all of the pre-built database that Django provides into the system so that this Django project can use that database files or maybe that database tables. Once this has been done, the last part is Python manage.py run server. Now, once you do this, yeah, it's taking a little time to load, but yeah, here you can see it has given me a development server, and you can click on this link, and when this link open, and you can see that the request resource was not found on this server. Okay, so we are getting a problem now. So if I see my settings.py, yes, see, why this is not running is because I set the debug is equal to false in my settings.py file. Now this is a very important file in Django, and changes done here are very important. And if changes done not right could give you error like it has given me. Now say let's just change this to true and see if the code is now working or not. Yeah. Okay. See, it is now working. Now you can see that there's a write a sentence, and if you write I am happy, you can see that the sentiment of the above sentence was positive sentiment. So the code is working now. So what I wanted to actually show you is that when debug is true, which is usually only for development time, you can see that there's a warning also given, don't run with debug turned on in production. That is when we actually implement this code and we have made all the necessary changes that we have to, then we can just push this code into production. And once we push this into production, you have to set this to false. Now you can see that here Django is already reloading and checking if there's any change in the code. If there is, then it handles that changes and then gives you the development server. Now here two things are very important to understand. You can see that there is a my site directory and there's a poll directory. My site directory is my project folder. Okay, where settings, URLs, WSGI files are present. Now these are very important files. You don't have to make changes in them unless they are very necessary or helps you in any way. Now this polls directory, this is my app directory. You can make an app by writing the code python manage.py start app. And similarly, you can make a project using Django admin start project. So if you are using this code, it will give you a my site directory, inside that a my site directory where your settings.py, url.py, vsji.py, all of it is present. If you write the code that I wrote before, you get a polls here. One thing is that I haven't mentioned, here you keep the name of your project. So if I write start project my site, then a project directory will be made and inside which you will get this. The next thing that we have to look at is views. Okay. Yeah, views, which is inside my polls directory. So views is a part implemented in Django where all of your templates, meaning all of your HTML files are rendered. Or you can say all of the work that is happening in the backend happens here. You can see there's an if statement calling out if the request is post, and then you can see that I'm taking the value from my HTML and keeping it in a variable called name. Now there's a final.pre you can see, which I'm going to explain in a minute, and I'm sending this variable value into this function. Now what is this? You can see the final.py. So we made a logistic regression model and we used it for our prediction. So I just saved the model. You can see that the frequency dictionary, I saved it as a pickle file and now I'm loading it here. Similarly, the values that I got for theta, I've saved and now using it here. Now I have the process tweet function, that is pre-processing function. I have my sigmoid function, extract features, and lastly predict tweet function. Oops, yeah, there's a pre that is predicting the actual tweet. Now I'm using my predict tweet function where I'm sending the sentence, that is my tweet, again my dictionary having all the data and my theta values. Now you can see that here our actual logistic regression model is at work and giving me a ypred value. Lastly, I'm checking if my ypred value is greater than 0.5. If it is, then that means that we have a positive sentiment. So here, what I'm sending is my tweet, or let's say a text data, which goes into the final.py predict tweet function. It gives me a numerical value, and if it is greater than 0.5, we have a positive sentiment. If it's equal to 0, then a neutral sentiment, else we have a negative sentiment. Now I'm looking, so the res variable is storing if it is a positive, negative, or neutral sentiment. Now I'm sending that data into my first HTML, that is my template, and as a context value. Now this context value goes here, and you can find that context value here in my template or HTML file. So with this, we come to the end at the second part of this course, that is web application building and using my logistic regression model for sentiment analysis. The last part is where we can use this code and make some little changes so that we can push this into production.
Heroku docs, or maybe just search it online. The next comes Procfile. Yeah, what is Procfile? So Procfile is basically telling Heroku that yeah, I have a WSGI of G unicorn and I'm going to use that. And the next thing that I've written is dash dash log file. So this is basically a command that is telling Heroku that if, whenever the app starts, give me a log file, meaning file containing all the actions that are happening inside my app or inside my server. So this comes in handy when you're debugging or maybe fixing an error. So both of these files have to be present, and along with it, if you can see, there's an nltk.txt. Now I have encountered error because I hadn't, used this nltk.txt file. So this is required by Heroku again to understand that your code is using Twitter samples dataset and stock words. Now Heroku doesn't inherently have all of these data, and whenever you are asking Heroku to install, from your requirements.txt file, it requirements.txt file has NLTK. So it will install NLTK and that exact version, but it won't install the corpus dataset. For that, you have to, you know, use this nltk.txt file to tell it, excluding the requirement.txt, you have to download this also. So once you have made an nltk.txt file, proc file, runtime.txt file, then we can move forward. So the first thing is to push your code to GitHub. If we are using Heroku, that we are actually, then they have provided us with a very simple way of uploading code for production. So you can go to your GitHub account and simply upload your code like I have done. Now you can see that there's a my site, polls, proc file, manage.py file. Yeah, all of this was present there also. And one thing that you can notice is that in my environments, it is telling me that yeah, a sentiment logistic Heroku is active. So what does this mean? This means that my, this whole repo is actually connected to my Heroku app and is active, meaning my site is actually up. So you can go to your Heroku account or make a new one. And once you do, you can see this new app, you know, click on it and you can see there's a create new app. Now it will take you to a page where you can specify your app name, choose a region. It only gives you two options, United States and Europe, and then create an app. Now I already created an app, so I'm not making a new one. But once you create an app, it will be shown in your dashboard. So I have already have an app, and inside your new app that you must have made, you can see overview, resources, deploy, metrics, and some other options. So first, go to your settings. Now inside settings, you have to add a build pack. Now you can see that I've already added one Heroku Python. So you must have not added anything because inherently Heroku doesn't do anything. You have to manually set up a build pack. So you just add a build pack and choose Python and then save changes. So once you have done this, Heroku now understands that your code is in Python and the server is actually required having a Python dependency so that your code would work in that server. Now next thing is you go to deploy. This is where the most labor has to be done, and now you can see that there are three options, meaning there are three options for deployment method. We use the GitHub option. So once you click on this, it would ask you to, connect to your repo. So first of all, it would ask you to, input your credentials for GitHub account. And once you do, it would set up your account and then it would ask you to write the name of the repo that you want to connect to it. So you can see that my account SIP27878 is now connected with this repo sentiment logistic Heroku. You can see that I can disconnect it also, and then you can go to the next part, that is automatic deploys. Now, automatic deploys are not what we are going to use because we have to build in CI or CD. The next thing we go for is manual deploy. Now, manual deploy is where we actually choose one of the branches inside our repo, which is, let's say, master for me, and then we go for deploy branch. Now, once you do this, it takes your code from your repo and feeds it into the server. And you can see that there's a build master with a key given, and inside that you can see that there's a using build pack. It has detected Heroku Python. Now it is taking all the specified version of Python from my runtime.txt. Now it has installed Python 7.1.10. Then it is taking all of the requirement.txt packages and setting that up. Now the next thing you can see is that it is downloading the NLTK corpora. It is doing that because I've already defined an nltk.txt file where Twitter samples and stop words were put in. Now you can see that it has run a manage.py collect static. Now this is the function which I was telling you about where the code, oh my god, it has already been done. Yeah, but let me just tell you about collect static. Okay, so this is the part where the server now makes that static files folder and puts all the static files input into that folder. And the command for that is collect static. Now, if no error occurs, you would see that there's a deploy to Heroku and there's a tick mark next to it, and you can view your app using this function. This button. Yeah, so I click on this button, and now you can see that there's a sentiment dash logistic dash Heroku dot Heroku app.com. So you take this, you know, this and put it in your my site settings here. Okay, there's another way you can do this before actually doing all of that, which I will show you next. But you can see that if I just put polls, and you can see my page has been loaded. Since this was the actual URLs, that's why the page is actually loaded when I put in polls. And you can just type in any of this like I'm happy, confirm submission. Yeah, see the positive sentiment. Now, if you don't want to do this way, what you can do is, let's say that I'm actually making a new app. Okay, create a new app, and the app name is, and it is, yeah, so I create a new app. Now see, you can see there's a settings which has no builder packs. You have to add builder packs here, and there's an option of open app. So once you click on this is given to you. Now you can take this part, okay, copy it and put in your allowed host here. Then push the code into your GitHub or maybe changes in the GitHub, and then do whatever I was doing before this. So yeah, this is the last part that I wanted to show you. Once you're able to do all of that, you can just directly push the code to production and use it however you want.